ఇక అంటూళ్ళు అంటూనే ఉంటుంది నువ్వు ఏమన్నా ఇప్పుడు ఈయనేమన్నా. Anyway, good morning to all of you again. So today we are going to, discuss the operators, like type of integral that we use, and also importance of that. So we are going to discuss today, okay? And which is very important in day-to-day life applications. Okay, let me. Right. So whenever you see the around 40 maximum strength, so then you can post that to open the don't. I don't want I want to increase every day. It should be like more than 40. I was expecting today, but you can take one a screenshot that shows the maximum strength of the day. Like it could be whenever you see the 40 or 39 highest, then post that number. I want to send that to the university, Usmania University. The strength they were asking every day, so we have to report that. I mean, I can also post the attendance link that I collected. So anyway, yeah, I can see 38 members join. Very good. Thank you so much, for showing the interest. And it's very important, beta. We have to attempt all classes. So coming to the our class, you all know that the vectors are the play a very important role in many applications, I would say. So here you can see various types of operators. What are actually operators? So, okay, let me see. Let me see. Give me 1 second. I have to use this, the digital pad to write on the slide, so that it should be like activity mode. Right. So these are the actually vector operators. What are the vector operators? We have a del. It's like a delta, but it's a del. We call it cross product and dot product. So we use these three, very important. And as you all know that, vectors, or the first vector, you should always remember that, it should be like, in the, if I write a vector, it should be like this. Sometimes you also write a bar. And when I write the a cap, this should be unit vector. Okay, this should be unit vector. Then here I can see that any vector basically it contain unit vectors. You can see here there is a unit I, J, K. So you can write it like A is equal to X. Like AX is a component, but any vector when you write it, Xi plus Yj plus Zk. Are you able to see the slide? I think I can see some fluctuations. Is it okay, Upender? Can you able to see slide? Any fluctuations?
Yes, sir.
Is there any fluctuations moving like
No, sir.
that? Okay, thank you. So the first
Yes,
year
sir.
vector representation I am writing here. This is fine. So what is the actually dot product and cross product? These things I think you have done in the intermediate level in mathematics and in physics also we have done that. So dot product and cross product, what are these? And these are very important. 40 member Upender, now you can uh, take a picture. Now there is a 40 number picture. You can take the screenshot. So dot product. When we use the dot product, this is important. Whenever, what is the condition that we have to use the dot product, and what when we have to use the cross product? These two things are very important when we have to use this. So dot product we also called divergence, diverge condition. Diverge means it's coming out of that. Like dot product. Cross product means curving. Like, basically you can see here examples I posted here. Dot means it's kind of scalar quantity. It is a scalar quantity. Dot product is a scalar. Whereas the vector cross product is a vector quantity. What is the meaning? What are the examples, sir, that we have to understand about that? So I would definitely say that dot product is equal to, if I say W is equal to, let me use the whiteboard. Whiteboard also there, right? Let me use the first whiteboard. Stop this. I want to use the whiteboard. Where is the whiteboard? Yes. Then it's I can use. Okay. So you all know that. So A dot B. So A dot B is the dot product of two vectors. Here A comma B are the two vectors. When I do the dot product of these two vectors, I get a scalar. Okay. But when I do the cross product of two vectors, I get a vector quantity. Okay. So then the question is, suppose let us take one example. How, like, I can take I want to calculate the work done. Okay. But I am considering a force vector, one of the vector force, let's say 2I minus J plus 3K. This is the force vector Newton. Okay. And the displacement vector also I'm going to take. Displacement, you have to remember that force and displacement are the vector quantities. Examples of the vector quantity. So I'm going to use this I plus J minus 2K. Okay. And this is the meters displacement. Now I am asking, what is the work done? Work done must be is equal to F dot S. So here dot product we are doing. So you can ask me, why can't we, why, I mean, we can also do the cross product. Why you are not doing the, why you are not doing
Yes.
the cross product, sir? I'll explain that. So dot product means when you are doing the dot product of two vectors, when you're doing the dot product of two vectors, joining students are joining, I would cancel it. When you're doing the dot product, you must remember that I dot I is equal to 1. Similarly, J dot J is equal to 1. K dot K is equal to 1. Why it should be 1? Does anyone knows this? Does anyone know that? Can you able to share your idea? Why it should be 1? Just and you can unmute and talk to me. Does anyone knows this? Why it? Does anyone prove it actually? I dot I is 1. Anybody? Volunteers? Who is anyone there
Yes,
to prove
sir.
this one? Anybody knows this? How can we
How
prove
it is
this?
possible?
Anyone, please volunteer. Please come and talk to me. Only one person unmute and talk to me. How can we prove this is I dot I is 1? And before that, I have to, I think you know that, but I have to teach this mod A dot B equal to mod A mod B cos theta. So remember, note down this. Oh, come on, Isha. Again, it's gone. Yeah, it's there. Yeah.